So Mongoose is one of several libraries that allows us to programmatically interact with MongoDB. There's quite a few out there. There's MongoDB has its own library. It's somewhat very low level, but certainly it's one of the better performer, and certainly it comes right from the folks who make the product. Although, again, it's a little too low level. And Mongoose provides a little bit higher level of abstraction that allows you to implement some of the things that we lost when we moved over from relational databases and we moved over to non-relational databases. Things such as schema, validation, all sorts of constraints that make things easier for us. Right? Some things that look like a join, that behave somewhat like a join, but they're not really. But they're very useful so that you can have references to other documents, and they can fill in those values if you want to. So Mongoose is somewhat the equivalent of what JPA might be for Java, right? That allows you to map a relational database into a object world. Here is not as it's not quite as jarring as the mapping of relational databases to an object world. Here, they're both objects, right? The data is natively being stored as an object, right? We just want to be able to retrieve them from the storage and then reinstantiate them in memory, either on a server or some application who's interacting with the database. Okay. So first. We're first going to have to learn a little bit about Node, right? Because we're going to be these libraries typically are being implemented. Since we are storing JSON and retrieving JSON and writing and updating JSON, JSON is native to JavaScript. Yes, so we're going to be using Node.js as the executable framework. And implementing our applications in JavaScript, right? JavaScript on the server. Usually, when folks think of JavaScript, they think of browsers and running on some on the client side for some UI. Not necessarily. We're going to be implementing server-side applications that interact with non-relational database. Okay. So let's do that. Let's bring up here. Another tab, and let's go into CS5200. Oops. And we had created something for this year and this semester, and in here, let's create a directory where we can play around with this. Okay. So we'll say make directory CS5200 server, but this will be a node server. So let's go in there, CS node. It's empty, there's nothing there. So we'll create a project, right? Just like you would with a Java project, we'll create a node project. So we'll say npm init. So first of all, just a couple of words on Node. Node. And the only thing Node is it's an interpreter. It's a JavaScript interpreter that allows you to execute JavaScript on a desktop, right, from the command line, as opposed to in a browser. Most folks, again, think of JavaScript as being executed on the browser, and so Node.js just allows it to implement things right on the console. Obviously, you lose a lot of things you take for granted on a browser. There is no UI. There are no buttons. There are no mouse. There's no UI, right? There's no windows, no alerts, or anything like that. Yes, but instead, when you're running at the console, you have full-blown access to the network. You have full-blown access to the file system. All sorts of things that you would not have access on a browser. You do have full access here, and you don't have the same constraints and security constraints that you would have on a browser. You don't have none of those here running on a full-fledged machine. All right, so when you install Node, you get at least two executables. You get the Node executable that allows you to execute JavaScript applications, and you get the npm. npm means Node Package Manager. It's the equivalent of a of Maven, right? In Java, Maven is a building tool, right? It allows you to install new packages, allows you to go fetch all sorts of libraries, download them, and install them locally. So npm plays that same role, right? One of the things that it can do is to initialize a new project. Npm init. Npm init asks a couple of questions. It says, what do you want to call your project? It takes the name of the directory as the default name of the project. And then it asks you a whole bunch of questions, version, description, entry point, test command, get keywords, me. And it says, OK. It generates a JSON object that represents your project. And it stores it in a file called package.json. Yes? Right? Which describes your project. And this package JSON file is the equivalent of a POM file in Java, in a Java project. Yes? You have pom.xml in Java. And the POM file describes a project. It's project object model. Yes? It describes your project. It also describes not only the name of the project, maybe the author. It also declares a whole bunch of dependencies. Right? What libraries does your project need to be compiled and run successfully? Yes? Package.json plays that same role. All right? Make sense? All right. Excellent. So let's create our first toy node application. So we'll say let's create it. We can open it up with our favorite IDE. Let's close this. Let's close this project. Let's close this too. Oh, geez. Anything else? All right, no. All right, so I'm going to open that directory I just created. 5200, 2019, fall, right here. This is OK. It parses it. It realizes that this is a node project. And there's nothing here, just package.json. That's all there is here. Are we OK? All right, so I'm gonna create here a file, and we're gonna be playing around with Mongo. So let's create a brand new JavaScript file, and we'll say Mongo. Actually, I won't call it Mongo because Mongo is already a command line, right? So we'll call it. I'll just call it server.js. Server.js is a very common name. Since Node is very famous for being able to create servers, HTTP servers, in 2 or 3 lines of code, and you got an HTTP server. Well, okay, so let's have our toy server here, and let's just say console log hello world. Okay, and as you would expect, this is the simplest hello world example. You can say node, and then server. And then it just runs. It interprets the file and runs it and executes it. And indeed, there we have a hello world. Everybody good? All right. Okay, so we're not gonna do much with JavaScript. Well, actually we are, but nothing. There's nothing earth-shattering. It's just a programming language like any other, and all the things you would expect are possible here. What's interesting that what we really want to be able to do is start interacting with Mongo. Yes? To do that, we're going to have to install Mongoose, the Mongoose library, which we just are introducing. And to do that, we are going to use npm. So npm, again, npm stands for Node Package Manager. So one of the things that we'd like to be able to do is install new packages. In this case, Mongoose. Mongoose, we'd like to install Mongoose. Let's do that. Say npm install, right, and then the name of the library. And I just happen to know that the library is called Mongoose. Right? If we do that, it's going to go and fetch the library from a repository, from a Node.js repository, which you can find at npm.js.com. And so here are a plethora of free open source modules, node modules, that anybody can contribute. I encourage you to perhaps create your own node modules and publish them here, and you can, folks can then do npm install, your very cool Node.js module, and then you can become famous and whatnot. So there's several packages that are very, very famous. They've changed this a bit, but you can search through here some of these libraries. Most of them are open source. Anyway, so Mongoose. I just installed Mongoose, and how do we use Mongoose to connect to the database? So Mongoose has its own Mongoosejs.com. It has its own website, and it's very well documented. I encourage you to go through their documentation. We're only going to use the tippy top, right, of the most common things that you would do with Mongoose, but there's plenty of stuff here that is very, very cool. And again, I encourage you to take a look at it. One of the things that we need to do is first load the library. Okay, the way we load the libraries in Node.js, it's very common, just like you would in any other language. In Java, you do imports. Yes, in C or C# you do includes. In Node.js, you do requires. Right? And the require, you name the library that you want, and it starts looking for the library inside of your project. See where it finds it. Yes. If your Mongoose, if your library doesn't start with a /, right? If it starts with a dot, you are literally telling it to start looking in my current directory and then start looking to see if it finds it. Yes. If you don't say, by default, it will look in this new directory that wasn't there before. Right? See that directory, node_modules, was not there before, right? It appeared when we did the npm install. Right? When we said npm install Mongoose, it downloaded Mongoose plus any other libraries that Mongoose depends on. Okay, it installed it and it put it inside of node_modules. There's actually quite a few things that Mongoose depends on. Here's our Mongoose. Notice in gray, that's the one we installed. But Mongoose depends on a whole bunch of other things. Yes? And it downloaded them and it copied them here. All right? In particular, it downloaded MongoDB. See that? MongoDB is the official MongoDB library that is made available by the MongoDB folks, right? That they create the product. Yes? And just Mongoose creates an abstraction layer on top of that, right, to make life a little bit easier for us. So MongoDB is like JDBC, right, which is very low level, right, and then Mongoose is like JPA, right. It creates a level of abstraction so you can think about the database in a much higher level. Make sense, right? And it deals with all the low level stuff for you, okay. And download a whole bunch of other things. One thing that we forgot, if we look at the package JSON, actually no, it worked. Notice that it added a section here that I didn't add before. When I first init the project, I never declared this dependency. But by doing the npm install Mongoose, right, it declared Mongoose as a dependency to my project. See that? So if anybody, if my module, if I publish it in npm and it becomes very, very famous, and folks start downloading my very famous package, and they do an npm install, Jose's great package, yes, it'll download me, obviously, plus Mongoose, plus anything that Mongoose depends. Make sense? So this package JSON creates all the dependencies so that anybody can install my package and load all the other dependencies. Everybody okay? All right. Excellent. So we have Mongoose installed, and let's have the server. Here's the server. So okay, so this loads the library and it gives me a reference to whatever this returns, whatever that returns. makes it available here at this variable, or this constant, sorry. Once I have the constant, I can, in this case, it's an object, so this guy can return a whole bunch of things, right? Right now, it's just returning an object. That object has an API, right? And one of the things that I can do with Mongoose is connect to the database. I can connect to the database, right? I can say MongoDB :/localhost 27,017. That's the default location. Or if I have my database hosted on MLab or on Heroku, or if it's hosted anywhere else in the world, half away the world, and the IP address, right? You can type in here the IP address of where your Mongo is connected somewhere in East Asia or something. I don't know. And then you're connected to that remote database. Everybody good? Also here we have the name of the database that we're connecting to. In our case, it's whiteboard, right? This is some optional configuration that we don't need. Once we have that, we're good. We can start connecting to the database. Mongoose Connect. We're connected to the database right there and then. We're connected. We can start interacting with the database. Everybody okay? All right. So I'm going to run it, see if it blows up. Node server. It connected. Okay, looks like it didn't explode. So it did connect to the Mongo client. All right. So it looks like it's connecting. All right. So how can we connect? How we can start interacting with the database? So one of the ways that we should be able to interact is by mapping somehow some object model here in our database with some data that is already stored in the database. Yes, we know in whiteboard we have, let's see, here we have show DBs. So we were trying to connect to this database, and indeed, hopefully we were able to do that by putting it right here, the name of the database. There it is. But then inside of that database, we have the users collection there. Okay, so we'd like to be able to retrieve data from here and update and delete and insert and whatnot. Yes. All right. So to do that in Mongo, we need to create a data model. Right? We have to create a data model that represents that data that is stored in there. Right. If I don't remember what we had here, db.users.find.pretty. So it looks like our data has the following structure, right? It has a username, first name, last name, salary. The first three seem to be strings. The last one seems to be a number. Right, so let's create that data model represented also in Mongoose. So let's do that. So to do that, in Mongoose, we can do as follows. We can say const user schema. Yeah, we're coming from a relational database. We're missing these schemas, right? And we seem like we lost them when we went over to the non-relational world. Well, here's our schema again, yes? But at the application level, not at the database level, right? This is being created at the application level. So we can say mongoose.schema, and we can describe now the schema. We can describe the structure of our data. Right? And we want to make sure that it validates against that schema, meaning it should refuse to insert things that do not match the schema. And that if I say it's a string and I try to insert a number, it should not allow me to do that. Okay? Right? So schema, Mongoose schema does allow me to establish some structure, some validation, some constraints, right, that I kind of had lost, when I was interacting directly with the database using Mongo, right? So here we can say that username, username, it's a string. First name is a string. Last name is a string. And we have salary is a number. Right? Maybe we have a date of birth is a date. Okay? All right. Once we have that, this is the equivalent of in Java having created an entity. right? Where we declare all the fields, all their data types, plus setters, getters, and constructors and whatnot. Yes? So this is the equivalent of having created a model class, a Java class. Make sense? The other thing that we need is the equivalent of a repository, right? In JPA, we have the concept of a repository, right? A repository is something that knows how to create, update, insert, delete, right? Anything that we tell it, and we have to tell what, right? The repository, when you configure, you have to say, oh, I want you to CRUD a user, or CRUD a movie, or CRUD, and then we give it some data model. Make sense? And then after it knows what it needs to insert and update and delete, you can then use some of the functions that are the default functions, right? You know, the repository has a find all, it has a delete, right? It has a find by ID. It has a lot of built-in functions that it exports and allows us to interact with the database. Yes, same thing here. Same thing here. Here in Mongoose jargon, those repositories are referred to as just models, right? The model, or sometimes we're going to refer to as the Mongoose model, right? So here we're going to create the user model, understanding that this is playing the role, right, of a DAO, of a data access object, right, that knows how to CRUD users in this case. Yes. All right. So to do this, we're going to say mongoose dot model lowercase, and then this model takes two arguments. One is how do we want to uniquely refer to this model, and two, what is the schema? Right? The schema makes sense, right? Because even in the repository, when we created the repository, we had to provide the Java data model, right? And say, oh, I want you to CRUD movies or users or whatever. We need to tell. Plus, we had to provide the primary key. Yes. Although it looks like the primary key is being handled by the database, we're not going to do anything with the primary key. So the first argument is a string, and I'm going to give it a unique identifier. It doesn't matter what you use here. It's a unique identifier as far as Mongoose is concerned, right? Mongoose, every time you create a model, it has to have a unique identifier, right? Comma, the schema. So in this case, it's the user schema, right? With the user schema, it will know how to insert, update, delete users. Yes? Exactly. Yep. Right. Exactly. Typically, there will be like a db.js, and that's the only place where you open up the connection. Yep. Exactly. All right. So now that we have the user model will provide all sorts of methods that would allow us to manipulate the interact with the data. Right. So for instance, you can say user model dot find. Right, user.find. So this .find is going to behave very much like the find in the console, right? So one of the things that the folks at Mongoose, what they try to do is to make the API of the library as much as possible as close to the what you actually would type at the console, right? Again, I think the only glaring difference is that instead of insert, there's a create, right? I think that's the only big glaring difference. But other than that, most of the commands that you would type here follow very much the same syntax that you would find also in the Mongo console. All right, so let's do find. Now here we would have perhaps const users. And we would perhaps do console.console log users. Let's see what that does. Okay. Okay, so notice that we still have that hello world at the end, right? But before that, we printed out users. Look what it printed. It's not quite what we expected, right? We were expecting these two users, right? This is what we were expecting. Instead, what we got is something different, okay? What we got is pretty much the entire API that we can still manipulate and keep interacting, right? What we get back here is not the data. What we get back is a object that allows us to talk to the database in an asynchronous fashion, right? Here we have the Nodejs is running in its own thread, right? Mongo is also running in its own thread, perhaps running in a separate server, half a way across the world. Yes, right. So this communication, this right here, right? That's an asynchronous call, right, out to the database. Yes. What you get back is not the actual data. What you get back is a way for you to register for a callback in the future for the server to respond to you and say, hey, here's your data. Right? One of the unfortunate things is that Node.js is single-threaded, right? And because it's single-threaded, you don't want to risk making a synchronous call and getting stuck here waiting for this response to resolve, right? Especially because this is some remote resource, right? It might take a while for this to come back, yes? And because you're single-threaded, you don't want to risk your single thread being stuck here. In Java, Java's multi-threaded. You can have all sorts of threads running around. It's fine if you have a thread waiting. You can have a whole bunch of other threads doing a whole bunch of things. Not here. It's single-threaded. So instead, what you get back is called a promise. A promise that at some point, hopefully soon, I will be able to resolve your answer. Okay? Right? And actually, that's fine. So that promise allows us to. The promise has it's an object. It's an object, and that object has a function on it called then. Right? The then function allows you to register for a callback and say, hey, notify me sometime in the future, right, when the data comes back. Right? I don't want to wait for it now. Right? Here's the function for you to call me, right? Notify me. Right? And that function could be, you can call it whatever you want. You can say, here's a function. Find or notify users. Okay, and ideally, this is the data that would come back, and I'm just going to do a console.data. Well, actually, that data hopefully is users. Hopefully, yes, and I can register this notify users right here. Right, that promise allows me to register. Yes. Very good. Yes. It's based on this name right here. It's based on that name, right? And that's going to give us a problem because my collection is called users, right? And let's see what happens here. Yeah, we still have just users. Right? If I would have inserted, what would have happened here is that I would have created a new collection based on this name, and it would have made it all lowercase, user model, right? And it would have capitalized it. Not capitalized. It would have made it plural, user models, right? And that's not the collection I want to map. Right? Very good catch. We have to explicitly. We can override that and say, no, don't try to guess what the collection is, right? Instead, I'm going to tell you exactly which collection to use, So in the schema, when I'm declaring the schema, I can tell you exactly which collection to use. It's users. Right? If I don't have this, this is optional. This one is optional. If I don't have that explicit mapping, right, it will try to derive it from the name that I give it here in the what I call the model, right? And then pluralize it, which is even worse. Okay. Okay, very good. So let's try this out. Let's run this, see if this blows up. Okay, there they are. Right. These are my users. It came back as an array of users. Right. Because I asked for all of them. I could ask for specific ones. Perhaps I can say all the things that I would expect that I can do in the console. I can also do here. I can say I want the one that has the username Ada. Right, so if I run this, right, notice that it only returns Ada. Makes sense, right? Okay. Let's play around with this, right? So let's create some data. Let's retrieve data. Also, another couple of things here. Notice that I have this function right here as notify users. Yes, there is a more concise implementation of this without the promise. Without the promise. Yes. This right here, the finder, just returns the object, yes? So I can put the then right here. Everybody good? All right, so if I run that, it does the same thing. Right? Also, I could just put it in the second line. Right? That still works. And this function, if this function is a throwaway function that I'm never going to use ever again, right? Something that is very, very common in JavaScript, and that's also becoming more and more common in Java as well, is to use anonymous functions, use lambdas. Lambda function that doesn't have a name, right? It's an anonymous function. You pass the data, and then it's never used again. It's only used here. So here, you can declare the function and say users. Notice it's anonymous. It doesn't have a name. And you can say here console log users. So I don't need this function anymore. Right, so if I run that again, it still works. Everybody okay? And right, this is the old JavaScript syntax. This is ES5. In the new syntax, ES6, this can become even more concise. Right? You can remove the function, right, and use instead the arrow syntax, right? Which again in Java you have very similar syntax as well, right? It's becoming more and more popular, right? And again, if I run it, it works the same. You can be even more concise. If you have just one single argument to the function, you don't need the parentheses, right? If you only have a single line of code, you don't need the curly brackets. Right, so this would become just that. Right, so that still works. Everybody okay? Right, so this is very, very common syntax. That's becoming more and more popular. Very, very concise. All right, excellent. Let's keep going. Let's create a couple of pieces of data. Right, so instead of find here, let's create something. Let's say user model dot create. Create behaves like the insert. Right? Again, I'd mentioned that this is perhaps the biggest difference, right, between the APIs and what you would type in the console. But it uses the same thing. It uses an object. Right, and you can say here's a username, and we'll create Dan, and first name Dan, and last name Brown. So this create is going to do the same thing. It's going to do an insert into a database, and then we can have a then is going to come back with the actual object that was inserted, right? So that we can see even the ID that was generated, right? It'll come back with whatever was inserted in the database, right? So here's the document that was inserted will come back to us, and we're just going to spit it out in the console. Right, so let's run that. Okay, there it is. So Daniel Brown, notice the ID that was generated, plus a version, _ v version. Right, so Mongoose keeps track of the version of objects that it has inserted. Right, so it can keep track of, oh, I'm managing this object, from the application. This was not created from the console. Right, this was created from the application. Right, so it keeps its own internal things, yes. And if we do a find, we do a user model dot find, then users, we can display all the users. And let's comment this out. So if we run this, presumably we're going to retrieve all the 3 objects, right? The 2 that we had inserted in the console, plus this new one that we just inserted from the command line, from the application. Yes? Yeah, exactly, right? So for instance, what happens if you would do something like this? That's a very good observation. Say I create now Charlie Brown, and once I create Charlie Brown, I want to retrieve all the users, right, and see if Charlie Brown made it in there. Okay, so what this has created is a what we call a race condition. Right, because both of them are asynchronous, right, and there's no guarantee in the order in which they will execute, right. So maybe 50% of the times you will see Charlie Brown as retrieved from the database, and 50% of the times you won't, even though it was inserted, but it was inserted after the find all, yes. So the order is not guaranteed. That's where the then comes in. The then allows you to guarantee the sequence of operation. Right, then says that, hey, I want these to happen in a particular order, right, that I want to retrieve after the insert. So let's do that, right? So this then happens right here, and what I want to do here is, here's the doc. I don't really care about the doc. Right, I want to do the find here, right? I'm gonna do this, and I want to put it right here. Oops. Now I'm guaranteed that the find will execute after the create. Yes, right? So let's try that out. So let's make sure first that Charlie's not here. So we have Ada, we have Tim, and we have Daniel. So there's no Charlie. So if we run, notice that now we have Ada, Tim Bisley, and Charlie, right? And Mongo, yeah, Charlie made it in there, so it is there. Yes. So we guarantee the order of operation. Although notice that what's happening here, right, is that we have this ugly indentation, right? We have this then, and then you have a user model. What if we had to do the same thing again? Something that would happen after the find. We would have to embed inside of the inner function. Yes. So you would start getting all this, skewed, right? All this skewed source code that would look awful, right? That would be very, very hard to follow along, right? As the data is embedded. Again, to implement the sequence, to guarantee the sequence of operation of something that is basically asynchronous. Yes. So what we could do is that, for instance, what if after retrieving all my users, I want to retrieve only Ada? What would I do? I would do this, right? I would do the console, and then I would do this. Okay, so here we have the doc. We can do a console for the doc. So here I'm printing the document I just inserted. Then I'm finding all the users, and then I'm printing all the users. And then finally, I am retrieving only Ada. Yes? And notice that to make sure that this happens in the order that I want, I had to embed them inside of the other. Yes? So notice how everything started to become skewed, because we want to enforce the sequence. Yes? So to avoid this, what we can do is the following. This right here, this find, right? This find, we want to use this then. Right? So what we could do is just, instead of putting it here, we can say return. Now this return will be what? The return of what? Of this then. Yes? So now we can move this then. We can move it down here. See that? Okay. We can do the same thing here with this finder. We can do a return, right? And then we can move this then. We can move it down here. Now it's much more readable. See that? Now it looks almost as if this was sequential. It's almost as if this read synchronously. Do this, then do this, then do this. That's the whole point of the then keyword, right? To make it look as if this were synchronous, even though these are all asynchronous calls. Everybody good? All right, so let's see if this actually works. Yes?
I have a question. Why the hello world is printed?
I'm sorry?
Why the hello world at the end of this? Why isn't it printed?
It didn't?
No.
Oh, it printed here.
Oh, so it's because of the synchronization.
Yeah. So we can't guarantee the order.
Okay.
Yeah. If you want to guarantee hello, then you have to put it somewhere in here. Right, then you have to guarantee, now you can guarantee the order, right? So anyway, so we did Charlie, Edward, Norton. And so let's insert that. Let's stop that. Let's run it. Okay, so notice that what happens, right? The first one is Ed was inserted. Then we retrieve all of them, including Ed, right? Because it was all of them. And then finally we did the hello, and we retrieve Ada. Right? We guarantee the order of operation. Everybody good? Okay. All right, a couple more things. So very much like we have, very much like we have DAOs in Java, or that we created an object that encapsulated all the operations, all the CRUD operations, and all the low-level operations using JDBC and whatnot, right? We created dedicated classes, right, that encapsulate all those things, right? So even if you're going to be using this, accessing it from multiple different places from your database, from your application, you don't want to use these all low-level stuff anywhere you want. You want to encapsulate this in reusable components, right? That you can then make use of this wherever you want in your application, right? So let's put some structure into this. So let's put some structure, okay?